Welcome back, dear students. Today we shall do some exercises from geometry on triangle. Exercise 1. In the quadrilateral ABCD given in the adjoining figure, AD is equal to BC. P, Q, R and S are midpoints of AB, BD, CD and AC respectively. Prove that PQRS is a rhombus. Here AD is equal to BC given. P, Q, R and S are midpoints of AB, BD, CD and AC respectively. We have to prove that quadrilateral PQRS is a rhombus. In triangle ABD, P and Q are the midpoints of AB and BD respectively. By midpoint theorem. PQ is parallel to AD and PQ is equal to half of AD. In triangle ACD, S and R are the midpoints of S is the midpoint of AC and R is the midpoint of CD and CD respectively. By midpoint theorem. By midpoint theorem, SR is parallel to AD and SR is equal to half of AD. SR is parallel to AD and SR is equal to half of AD. This is 1, this is 2. From 1 and 2 we have PQ is parallel to AD and SR also is parallel to AD, implies PQ is parallel to SR. Again, PQ is equal to half of AD and SR is also half of AD, implies PQ is equal to SR. Therefore, from the diagram, we see that in quadrilateral PQRS, PQ is parallel to SR and PQ is equal to SR. So the opposite sides, a pair of opposite sides of the quadrilateral PQRS are equal and parallel. Therefore, PQRS is a parallelogram. Therefore, since a pair of opposite sides of the quadrilateral are equal and parallel, that is PQ quadrilateral PQRS are equal and parallel, that is PQ is equal to SR and PQ is parallel to SR. Implies PQRS is a parallelogram. So we proved that PQRS is a parallelogram, but we have to prove that PQRS is a rhombus. So we have to prove that in parallelogram PQRS, the adjacent sides of the parallelogram are equal. Therefore, if the adjacent sides of the parallelogram are equal, then it becomes a rhombus. Therefore, now in triangle ABC, in triangle ABC, P is the midpoint of AB and S is the midpoint of AC. Therefore, PS is parallel to BC and PS is equal to half of BC. So in triangle ABC, P and S are the midpoints of AB and AC respectively. In triangle ABC, P and S are the midpoints of AB and AC respectively. Therefore, by midpoint theorem, PS is parallel to BC and PS is equal to half of BC. Now PS is equal to half of BC. Now it is given that AD is equal to BC. Therefore, in place of BC, we can write half of AD. Since AD is equal to BC, this is 3. From one and 3, we have PQ is equal to half of AD and PS is also half of AD, implies PQ is equal to PS. Therefore, we proved that the adjacent sides of the parallelogram PQRS, that is PQ and PS, are equal. So, in parallelogram PQRS, the adjacent sides PQ is equal to PS. Therefore, PQRS quadrilateral PQRS parallelogram is a rhombus. So, therefore, in parallelogram PQRS, the two adjacent sides PQ and PS are equal. Therefore, PQRS parallelogram is a rhombus. Therefore, we proved that PQRS is a rhombus. Proved. Exercise 2. In the adjoining figure, ABCD is a parallelogram and E is midpoint of AD. DL is parallel to EB, meets AB produced at F. Prove that B is midpoint of AF and EB is equal to LF. Here E is the midpoint of AD and DL is parallel to EB. DL is parallel to EB. Given implies DF is parallel to EB. DF is parallel to EB. In triangle AFD, E is the midpoint of AD. E is the midpoint of AD given and EB is parallel to DF. From 1. Therefore, by converse of midpoint theorem, B is the midpoint of AF. So B is the midpoint of AF. Proved. Now we have to prove that EB is equal to LF. Since ABCD is a parallelogram, therefore BC is parallel to AD, implies BL is parallel to AD. Now in triangle AFD again, we have BL is parallel to AD and B is the midpoint. B is the midpoint of AF, already proved, and B is the midpoint of AF, already proved. Therefore, by converse of midpoint theorem, L is the midpoint of DF. Now I missed one thing here. B is the midpoint of AF and B is the midpoint of AF. And BE is equal to half of DF. This is 2. Here BE is equal to half of DF. Since DL is DF is parallel to EB and E is the midpoint of AD, therefore B is the midpoint of AF, therefore EB is equal to half of DF. It is 2. L is the midpoint of, here by converse of midpoint theorem, L is the midpoint of DF, implies DL is equal to LF. Implies LF is equal to LF is equal to half of DF, half of DF. This is 3. Now from 2 and 3, from 2 and 3, from 2 and 3, BE is equal to half of DF and LF is equal to half of DF. Implies BE or EB 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 is equal to LF. Here EB is equal to half of DF. Hence EB is equal to half of DF. Hence we proved that B is the midpoint of AF and EB is equal to LF. Proved. Thank you very much for watching my channel. Please like, share and subscribe my channel, and to get the latest updates, press the bell icon. Thank you.